Hi everyone, I hope you are doing good. So today in this video we will take a new DSA question and that is diameter of a binary tree. So I hope you have watched my last video where we have discussed the maximum path sum in a binary tree. So this is the similar questions. There we have to basically calculate the maximum path sum, right? The values of the nodes in that path and that sum should be maximum in that given binary tree. Here we have to calculate the edges. So let's understand the question. Given a binary tree and the given a binary tree, right? And in that binary tree, the diameter, also known as the width, is defined as the number of edges on the longest path between two leaf nodes in the tree, right? The path may or may not pass through the root. Your task is to find the diameter of the tree. Did you understand the diameter? Diameter is you have to leaf the path. The length of the path should be is a diameter basically. So here this is the leaf node. This is the leaf node. So the path, this one, right? This and this. So this is the diameter. Here one edge is this one. Second edge is this one. So the diameter of this given binary tree should be 2. Correct? I hope you are getting. The one more thing here. It is mentioned that the path may or may not pass through the root. So let's take another example here. 1, then this is 2, then this is 3, then this is 4, this is 6, whatever, right? This is 7, this is 8, then 1, 2, 3, 4, 1, 2, 3, 4, and then this is 9, and this is 10. So let's take this example here. So basically I took this example to prove this the path may or may not pass through the root, right? So here the maximum diameter, if we calculate, then that is not going through the root. Root is, this one is our root, right? So here 1, 2, 3, 4, 5. So if we go through the root, then our diameter is 5. Correct. But if we do not go through there, and if we calculate this path, then 1, 2, 3, 4, 5, 6, our diameter is 6, right? So maximum the length of the path is 6, right? It is passing through 6 edges. And if we include the diameter, if we go through this path, this one, then this is 5 only, right? So our result would be, or output would be 6, right? It should be 6. The other example, if we take, so here this is another example. If we try to understand, calculate the diameter here. So the one edge is this one. If we go through this, then it is 2 only. Then if we go up, then here 2, then here 3, and here 4. So here output should be 4, right? Or diameter, the result should be 4. So I hope you now understand what is diameter and how can we calculate that. Correct. So now think about the solutions. What could be the solution here? And if you relate this problem with the last problem, whatever we discussed, right? If you haven't watched that video yet, then please go through that video and watch that. Then it would be very easy for you, because it is similar kind of questions. There we used to have the maximum path sum. Here we are just calculating the diameter. Instead of the node values, we are here basically calculating the edges, number of edges, right? So what my solution is for this problem is, so let me so what I will do, I will basically add a helper function, right, separate, and where we will calculate the RES. So for example, calculate dia, dia, then I will here take the node, right? So root, and here as a reference I will take result. So in this result I will store the this number of edges basically, and this would be your result, right? And here the return value of this one would be int, right? And here what I will do, I will check if instead of okay, let's take it root only. Root is null, right? If it is null, then return 0. Correct. If it is not null, then what I will do, I will calculate for the left side. So left, I will call again this recursively. calculate dia, then I will go root arrow left, and then I will say res. And for right also I will do the same thing, calculate dia, and then root arrow right, and then res. And here after this what I will do, I will update this res. So res is equals to maximum of res and then left plus right. So I will explain this, don't worry. And after this what I will do, I will return maximum of left and right plus 1. That is what I will return, and this would be our function, right? So here why I added this one, so let me explain this one. So first what I will do, I will go here, from here I will start, I will come here, left, right, and then from here I will call the left, right? Left is null, so it will return 0. So here left value would be 0, right? Then I will go right side and come back, so right would be 0, right? Because there is no node, so there will not be any edge, correct? I hope you are getting it. After this what I will do, I will come here down, and then I will calculate the res. So res is 0 itself, initially it would be 0, right? So 0 and left plus right, that is also 0 0. So maximum of 0 0 0 would be 0 only, right? So here what I will return, 0 plus 1. So if I come back from here, then here the left would be 1 basically, right? Because we are coming back and we are returning maximum of left right plus 1, right? Why plus 1? Because this is the correct node, right? And we are returning to the parent node. So between parent and this child there would be one edge. That is why we are returning here. I have added here 1, correct? So here left would be 1. Then after this I will call for right also, right? This one. So I will go here and I will call left for this one, right? Because it is not null, then it will call left, right? So left, it will come back, so left would be 0. Then for right also it go and come back, right would be 0, right? And here temp would be 0, and here res, see here res would be 0 initially, still res is 0, right? We did not update because for this left plus right is 0 and res itself is 0. So maximum of 0 0 is 0 only, right? So now from here we will come back, and here right would be 1, right? This time because this is 0, maximum of 0 comma 0 is 0 plus 1, that is 1, right? So now right is 1, and now from here after this call, we will calculate the maximum of res comma left plus right. So res is 0 itself initially, right? So let me add it here. Res is 0 initially. So now left is 1, right is 1. So 1 plus 1, that is 2. 2 comma 0, the maximum is 2. So it will be updated. It is 2 now, right? And I hope you can connect it, right? Because we have one edge this one and one edge this one. So that is why it is becoming 2, correct? And then here we are returning maximum of left comma right plus 1, that is 1. This is 1, this is 1, left is 1, right is 1, and we are adding 1, so we will return 2 basically. But we will not care about that, because we are returning to the main function from where we are calling this calculate dia. We are concerned about this res, right? We are concerned about this res because this is our final result, correct? So I hope you are getting this one. So let me clear this one and show you the main code. So we have already dry run the code for this example. Let's take another example here. So for example this one. So here this is the code. So this is our main function, right? From where we are calling this our helper function longest path, right? So here the function name is longest path instead of the calculate dia, right? So here we are passing the root, then we are passing the res. Res is integer min value, or you can take it 0 as well, that is also fine, right? Because the number of edges would be positive. It never never can be a negative value, right? So you can take 0 as well, that is fine. And in this function we are taking it as a reference, so that whenever we update the RES, then it will be updated for all the nodes, correct? So now here root is 0, in that case we are returning 0, and we are calling for left and we are calling for right, and here we are updating the RES is equals to maximum of RES and left plus right. Right, I hope you are getting it. And then here I have added carry, separate variable basically, and then we are returning carry plus 1, right? So this is the code. Let's do the dry run for this example as well. So we will call the root here, then root arrow left, right? So from here we will come here, then we will come here, and then we will come here. From here we will return back. So here left would be 0, then here right would be 0, because we come here and then we come back, correct? Right, and then here then we will calculate RES. So RES initially would be 0, so 0 plus 0, that is 0. So here RES would be 0, and here temp would be 0, right? Because 0 comma 0, the maximum of 0 comma 0 is 0, and we will return this, basically this is carry, so carry plus 1, 0 plus 1, that is 1. So from where whenever we come back, then here the left would be 1, right? Because this is, we are returning for left, correct? And then from here we will go this side also and do the same thing whatever here, because this is the leaf node. So here left right would be 0, and from here when we come back, then here right would be 1, right? And then left and right is 1. So now we will update the RES, because left plus right, that is 2, 1 plus 1, that is 2, RES is 0 itself. So here the RES would be now 2, because 0 comma 2 maximum is 2, so it will be updated RES value, right? And here this carry, so carry will be also updated. Here carry is 1 comma 1, so the maximum would be 1. So here we will return 2, carry plus 1. So from here if we go back, then here left would be 2, right? And I hope you can connect it, right? Why it is 2? Because when we come back from this valid node to the parent node, then there would be a 1 edge, right? And here in this side, left side, we have 2 edge, 1 and 2, either this or this, right? And why we are taking maximum? Because like edge we have already discussed, like there is no need to include the root node. It could be a maximum path below also, right? In subtree also, correct? So for example, this is the node 2, then this is 3, this is 4, right? This is 5, this is 6, right? So now here this is 1, right? Left is 1, here right is 1, here left is 2, and here if we come back, right is 1 and left is 2. So now if we go from here, then which path should we take? We should consider the maximum one only, right? This one only instead of the 1, correct? So that is why we are taking the maximum value, right? I hope you are getting it. We are taking this maximum 1 and 2, right? And from this right side we are having only 1 edge, and the left side we are having 2 edge at this point. And from here if we pass the result, the value to the parent, then we should pass 2 instead of 1, because we are considering the maximum. We should consider the maximum. We are looking for the maximum diameter, right? So let me clear this one. So I hope you are getting why we are taking the maximum, right? So left is 2 now, and then we will come right and we will do the same operation here for right. So for this one, left would be 0, right would be 0, and here left would be 1, and here right would be 0, because we do not have right node for this node, right? 6. And then from here if we come back, then here right would be 2, because left comma right is 1 comma 0, the maximum of 1 comma 0 is 1, right? So 1 plus 1, that is 2, so we will return right is 2 here, correct? And then we will calculate the we will update the RES, right? So let's see, RES is 2, right? RES itself is 2. Now 2 plus 2, that is 4, right? This is 2, this is 4, so maximum is 4. So we will update this RES to maximum value, that is 4, right? And that would be your result. And from here then we will return a maximum of left comma right plus 1, right? That is here if we say carry that is 2, and we will return 3, right, from here to main function, means here, from here to here. But we are concerning about 4 here in the main function, from where we are calling this longest path, right? We are not, see here, we are not storing this returned value. We are just checking, we are just using this res to return to main function, right? So our result is 4 now. And how it is 4? See, 1, then 2, then 3, then 4, right? So this is the diameter, or longest diameter, or you can say longest path, basically leaf to leaf node. So I hope you understood this problem, you understood the solution, whatever I have explained. Still, if you have any doubt, query, then you can comment below the video. And if you want this code also, then you can also comment. I will share this path to you, and then you can use this code. Correct. So that's all for today. Yeah, one more thing. If you are having any difficulty while understanding this one, please watch my last video where this is the similar approach to that. And there we used to add the node values instead of this edge, right? So that would be very helpful for you. I will attach that link in the I button also. So that's all for today. See you next time. Till then, keep learning and keep exploring. Bye bye. Thank you.